Welcome to i4 Institute. My name is Khushbu and I am working as .NET software developer in i4 Technolabs Private Limited. We discussed and learned about basic SQL in our previous session. Now we are going to talk about advanced SQL. In this session, we are going to cover up all the following points: SQL commands, create, select, insert, update and delete, group by and having clause, joins, store procedures, functions, views, triggers, cursors, SQL Server version history, and management studio. In our previous session, we already learned about create statement, select statement, insert statement, update statement, and delete statement. Some of the new points are group by and having clause, joins, store procedures, functions, views, triggers, etc., which we will cover up in this session. So let's move forward. SQL commands. Some of the most SQL commands are select, that extracts data from a database, update, that updates a data in a database, delete, that deletes a data from a database, inserts a new data into a database, create database, that creates a new database, alter database, that modifies a database, create table, that creates a new table, alter table, that modifies a table, drop table, that deletes a table, create index, that creates an index, drop index, that deletes an index. We have here to create a command for creating a database. So let's see. The command for creating a new database is create database, database name. Whatever you want to put as your database name, you have to write instead of db name your database name. This is a simple create database statement. Database tables can be added with a create table statement. Now let's watch in detail for creating database table. It is used to create a table in a database. Tables are organized into rows and columns, and each table must have a name, which we already learned in our previous session. Here we have an example of table creation query where we can specify columns, data types, and their sizes. You can see here syntax is create table, table name, column name 1, data type and its size. Similarly, the number of columns you want to insert with their column names, then their data type, and then their size. The column name parameter specifies the name of the table, which I already told you. The data type parameter specifies what type of data the column can hold. If it is an integer, then it must have an integer value. If it is a varchar, then it must be a varchar value. If it is a bit, then it must be a true or false, that is 0 or 1. The size parameter specifies the maximum length of the column of the table. As I tell you, if it is an integer size and integer type, and if I have written 50, then only 50 integer character it will take. If it is a varchar type and if I have written size 50, then only 50 characters it will take. Now we have select statements whose general purpose is to display data from a table or views. Let's have a look at the select statement. As I already told you, the result is stored in a result table called the result set. The syntax is select column names, that is column name 1, column name 2, whatever name of the column in your table from table name. If you want each and every column of the table to be displayed, then you have to just write select star from table name. It will fetch all the columns data and display in your result set. Now insert into statement. We can insert records by using the insert command, which we already learned in our previous session. So let's have a look to the syntax of insert into statement. Insert into table name values, that is value 1, value 2, value 3 up to the number of columns you want, up to the number of columns you have and the values you want to insert. This is a simple insert into statement. Second form of specifies both the both the column names and values to be inserted. Suppose you want to insert only if you have a table having a 5 columns but you want to just insert data into 3 columns, then you have to specify the column name and then the values you want to insert in column name. So the syntax is insert into table name bracket open column 1, column 2, column 3 up to whatever columns you want, values value 1, value 2, value 3, etc. Same we have here for update statements. Used to update existing record in a table. So syntax is update table name set the column you want to the value you want to change for a column. So set column 1 equal to value 1, column 2 equal to value 1, and where condition if some of the condition you want to insert. The syntax of this is as simple as other syntax. So delete statement is used to delete records in a table. Similarly, the syntax for delete statement is delete from table name where some column equal to some value according to the condition you want to delete the record from your table name. It will record and it will delete an entire row from the table. It means the record which specifies or which satisfy the condition, it will delete the records according to that condition. So there is no existence of that record from table name once the delete statement is run. It is possible to delete all the rows in a table without deleting the table. This means that table structure, attributes and indexes will be intact. You can see here delete from table name or delete star from table name. Apart from the basic SQL statement, here we have group by statement as well. It allows grouping of records. Group by statement used in conjunction with the aggregate function to group the result set by one or more columns. SQL group by syntax is here. You can have a look. Select column name, aggregate function into a column name from table name where column name operator value group by column name. SQL having clause. The SQL having clause was added to SQL because the where keyword could not be used with aggregate function. So if you want, suppose there is a condition where you want a maximum salary from a table employee. So you will group by on basis of maximum salary. But now you want to add a condition where maximum salary is greater than 5,000. So you have to use having syntax with group by statement. Let's have a look for a having syntax. Here is an example. You can see select column name, aggregate function, whatever you want to use, max, mean, and average, whatever, from table name where column name operator value, whatever condition you want to add in a where clause, group by column name having aggregate function of column name operator value. It means suppose I want a maximum of salary, then max of salary greater than 5,000. Whatever condition you want to add. This is a simple group by and having clause. Now we have SQL joins. These are the most important part of SQL when displaying records from two different tables. Let's have a look. As I already told you, used to combine rows from two or more tables. It is used to combine rows from two or more tables based on a common field between them. The most common type of SQL is SQL inner join. SQL inner join returns all rows from multiple tables where the join condition is met. There are different Inner join returns all the rows where there is at least one match in both the tables. Syntax is select table1 dot column name table2 dot column name from table1 inner join table2 on table1 dot column name equal to table2 dot column name on table1 dot column name equal to table2 dot column name is must be according to the reference you have given in both the tables. Left join. Return all the rows from the left table and match rows from the right table. You can see here this syntax. It will show all the records from a table 1 but only the similar records or matched record from table 2. Right join returns all rows from the right table and matched rows from the left table. Syntax is like this. It will show all the records of table 2 but only the matched record from table 1. Full join returns all the rows from both the table where there is a match in one of the table. You can see here the syntax of full join. Different SQL joins have also a self join. It is used to join a table to itself as if the table were two tables, temporarily renaming at least one table in SQL statement. Here is the syntax for SQL self join. Example is like, suppose you have a customer table and you have ID, name and salary, and you want to give a if you want to give a self join, then select ID, name, salary from customers, that is first table, commas customers B, that is second table, where A dot salary is less than B dot salary. So here you can see that customers of A will be a temporary table and customers B will be another second temporary table. So we are comparing customers A with customers B. Let me give you an example for an inner join. Select star from employee, inner join department on employee dot employee ID equal to department dot department ID. Department dot employee ID. In employee table, there is a foreign key reference of employee ID from employee table. Let me run this statement. You can see here I have all the records from both the table employee and department which have foreign key reference of employee table employee ID. So you can see here the employee ID having 100 have a department ID 1 as well as department ID 6. It means that employee ID 101 is belonging to both the department, that is a tester as well as senior engineer. This is a simple example of an inner join. Now let me show you an example for a group by also. So suppose select name, comma, employee ID from department group by name, comma, employee ID. Let me run this. You can see here from a department table, it is a grouped by both the name and employee ID. You can see here the fourth field, that is marketing, having a null employee ID, which means that marketing position have no employees. This is a simple employee group by query. Now let me show you a next group by query with having clause. Suppose I am using same this. Suppose I am adding a condition that is having clause with employee ID greater than 100. It will behave same as a where clause. Let me run this. You can see here no record is here present having a employee ID 100. Every record is greater than employee ID 100, that is 101 and 102. This is a simple queries for group by and inner join. Now we have store procedures. It is a group of SQL statements and executed all together within a one body. SQL store procedure is a group of SQL statements that has been created and stored in the database. It will accept input parameters so that single procedure can be used over the network by several clients using a different input data. It will reduce network traffic and increase the performance. If we modify store procedure, all the clients will get updated store procedure. Here is simple syntax for creating a store procedure. You have to just write create procedure, name of your procedure as your statement, select statement or whatever you want to do. Go execute execute your store procedure and go. It will just execute your store procedure. Mostly store procedure is used when you want a input parameter from users. So different user have a different input parameter. So you have to just take that input parameter, just send that input parameter to your store procedure. It will give data according to that input parameter. Let me show you a simple example for creating a store procedure. Let me create a new let me create a procedure for you. Create procedure SP test as select star from employee go. It will create a store procedure with name SP test. Now I want to execute the created store procedure, so I will write execute SP underscore test and then go. Let me run this. You can see here I have a store procedure SP test and I run the or I executed SP test, it will give me a record from all the records from employee. Similarly, you can create a store procedure with your conditions, with your input parameters and whatever you want as a table to display. You can also create store procedure for insert command, update command, delete command. Based on that, it will insert, update or delete records on basis of input parameters you have passed in your store procedure. Now, let's move to functions. Special kind of stored program that returns a single value. You use function to encapsulate common formulas or business rules that are usable among SQL statements or stored programs. Suppose you want addition of two numbers or any of the mathematical equations you want, then we can use SQL functions for the same. There is a simple syntax for creating a SQL function, that is create function, the name of the function you want and parameters you want to be used in your statement. Function must always return a type, so you have to do a return data type, not deterministic statement. Now you have a different question in your mind, that is what is difference between a function and store procedure, because both are used for getting a record based on the parameters. Then what are the difference between a function and store procedure? So let's move forward with difference between functions and store procedures. Here is a simple comparison between a function and store procedure. Function must return a value, it is mandatory. In store procedure, it is optional. In function, it will allow only input parameter, doesn't support output parameters. But in store procedure, it supports both input and output parameters. It can be called from a procedure. Functions can be called from a procedure, but procedures cannot be called from a function. Function allows only a select statement in it, but store procedure allows any of the DML statement, that is insert, update, delete. Function will not allow us to use try-catch blocks, but store procedure will used for exceptional handling. Function can use only table variables. It will not allow using a temporary tables, but store procedure can use both table variable as well as temporary table in it. Functions can be called from a select statement, but store procedure can't be called from select, where, having and so on statements. Execute or exec statement can be used to call or execute store procedure. Now we have views. When user want to see a specific data instead of entire table or tables join, we use views. Let's have a look at an example. In some cases, it is not desirable for all users to see the entire logical model. That is all the actual relations stored in a database. So consider a person who needs to know a customer name, loan number and branch name, but has no need to see the loan amount. This person should see a relation described in SQL by select customer name, borrower.loan number, branch name from borrower, comma loan, where borrower.loan number equal to loan.loan number. It provides a mechanism to hide a certain data from the view of certain users. Any relation that is not to be conceptual model but is made visible to a user as a virtual relation is called a view. You can also say that view is nothing but a temporary table which we can use in our entire network. Let's create a view for an employee table where only we want employees which are active now. So let me create a view for this. I am creating a view. Create view. Name of the view will be employee by active. As now I am writing my select statement. Select star from employee where is active equal to 1. I am running this. Now let me show you. You can see here I just run or executed a view by writing a simple select statement, that is select star from employee by active, which is my view name. It had just displayed the query which it just displayed the records which have is active equal to 1. This is the condition in my view, so it just extracted that condition. This is a simple use for simple example for using a view. Special kind of store procedure that executes in response to certain action on the table, like insertion, deletion, or updating of a table. It is a database object which is bound to a table and executed automatically. You can't explicitly invoke triggers. Type of triggers are after triggers or instead of triggers. Now what are after triggers? This trigger runs after an insert, update, delete on a table. They are not supported for views. Once I run a insert, update or delete table, automatically the trigger will run, and on basis of trigger it will show the output. After triggers can be classified further into 3 types as SERT trigger. This trigger is fired after an insert on the table. After update trigger is fired after an update of the table. After delete trigger, this trigger is fired after a delete on the table. Instead of triggers, this can be used as an interceptor for anything that anyone tried to do on our table or a view. Instead of triggers can be classified into further 3 types. Instead of insert trigger. This trigger is fired instead of an insert on the table. Suppose I am running an insert query, then first of all it will fire instead of insert trigger. It will fire instead of insert statement. Now instead of update trigger. This trigger is fired instead of an update on the table. Instead of delete trigger, this trigger is fired instead of delete on the table. Example of a trigger. You can see here there is a simple example which we have created for after insert trigger. So it is a example showing insert create trigger after insert on table employee test. For after or instead of, that is insert, update and delete, as the query or whatever conditions whatever data you want to manipulate. So your logic will be inside a trigger. It will fire. Now we have cursors. These are used when we want to work on row by row instead of all the data get from a select statement. Database object to retrieve data from a result set one row at a time instead of SQL commands that operate on all the rows in the result set at one time. Use cursors when we need to update records in a database table in singleton fashion, means row by row. It is nothing but for loop of SQL. Here is the simple syntax for using a cursor. Declare the name of the cursor you want and cursor. Local or global defines the cursor scope. Forward only and scroll defines the cursor movement, that is forward or a backward. Static, keyset and dynamic fast forward. This is a basic type of a cursor. Read only, scroll logs and optimizate defines the logs you want. For, that is a select statement, defines a SQL select statement. For update defines a column that need to be updated. Open, that is open global cursor name, that is by default it is a local, so you have, if you want it to be global, you have to write global keyword. Here is an example of a cursor. Now we are going to look at the SQL Server versions and check the difference between the different versions from 2008 to 2016. So what are the difference between SQL 2000 and SQL 2005? In 2000, no XML data type is introduced, but 2005 have this functionality. In 2000, we can create maximum of 65535 databases. But in SQL 2005, we can create 2 to the power 2 raised to 20 minus 1 databases. In 2000, there is no exceptional handling, but in 2005, there is exceptional handling. In 2000, we can't compress the tables and indexes, but in 2005, we can do this. In 2000, there is no varchar max or var binary max is available, but in 2005, this is available. In 2000, pivot and unpivot function are not used, but 2005 we can use. In 2000, can't bulk copy update. In 2005, it is introduced. In 2000, we can't encrypt the database, but in 2005, we can encrypt the database. Similarly, difference between a 2005 and 2008. The advanced version in 2008 have following new functionality is introduced backup encryption, which is not in 2005. XML data type is implemented and used. File stream is also introduced in 2008. Link queue is also introduced in for retrieving multiple type of data. Merge statement is also included in 2008. Table valued parameter is also introduced in 2008, and data synchronize is also introduced in 2008. Now 2008 and 2008 R2. In 2008 there is a maximum of 64 logical process, but in 2008 R2 there is maximum of 256 logical process. Master data services part of BI is not included in 2008. Master data service part of BI is included in SQL 2008 R2. Power pivot in BI is not implemented in 2008, but in 2008 R2 it is implemented. Geospatial data types are also included in SQL 2008 R2. SQL 2008 and SQL 2012. 2008 can support only 1000 partitions. 2012 supports 15,000 partitions. 2008 uses 27-bit precision for spatial, but 2012 uses 48-bit precision. String function concate and format are not available in 2008, but string function concate and format are available in 2012. Analysis services in SQL Server not have BI concept. Analysis services will include a new BISM with 3-layer model. There are new features for SQL 2014. So let's have a look. That is new cardinality estimator. It improves the execution plans that we are seeing for some of our complex queries which are taking a more time to run, and definitely assist with the ascending key problem. Always on enhancement. Microsoft has enhanced always on integration by expanding the maximum number of secondary replicas from 4 to 8. Readable secondary replicas are now also available for read workloads even when the primary replica is unavailable. In addition, SQL Server 2014 provides the new Add Azure Replica wizard, which helps you to create asynchronous secondary replica in Windows Azure. Delayed durability. In-memory OLTP. SQL Server 2014 enables memory optimization of selected tables and stored procedures. Updatable column store indexes are also a new feature. SSD buffer pool extension is another new feature. storage of input-output control. Now 2016 compared to 2014. The query store features maintain a history of query execution plans with their performance data, and that quickly identifies queries that have gotten slower recently, allowing administrator or developers to force the use of an old better plan if needed. Poly-based, this feature will benefit you if your regular data processing involves dealing with lot of large text files. They can be stored in Azure Blob Storage or Hadoop and queried as if they were database tables. Stretch database, JSON support, row-level security, always encrypted, in-memory enhancement. These are some of the references. These are some of the references which you can have a look for further reference. Let's complete the session of SQL. Thank you.